Hello everyone and welcome to the Introduction to Telepresence session. My name is Daniel Bryant, I'm the Product Architect at Datawire and I'll be the presenter for this session. Let's get started. Now at the beginning of all my talks I like to do a high-level TLDR or a kind of key takeaway slide. What we're going to be talking about in the next 20 minutes is that when you move to microservices and Kubernetes, the inner development loop can be quite painful. Now, Telepresence, the project we're going to be talking about today, proxies your local development machine into a remote Kubernetes cluster, removing some of that dev loop pain. Telepresence supports several workflows, whether your team is small or large, whether your organization, small or large, and depending on where you are in the business cycle too. Are you experimenting? Do you have product market fit? These kind of things. There is ongoing work for splitting the client and cluster components within Telepresence. So we'll talk a bit more about that and where the future of the project is going to go. And finally, Telepresence is a CNCF Sandbox project. One of the goals of the maintainer track is to raise awareness of the projects, and we would love to have more contributions to this project. So I'll give you some websites at the end, some Slack addresses and so forth, that if you do want to get involved with Telepresence, we'd love to see your involvement. We'd love to see you on the various forums, and I'll let you know how you can do that too. So let's set the scene. Great blog post here by Mitch Denny, and he talks a lot about the inner and the outer dev loop. Now, the inner loop, as developers, we're all too familiar with. It's that code, build, test cycle. Often you're doing, say, perhaps TDD, test-driven development. You may be creating some failing tests, coding to make the tests pass, and you may be mocking and stubbing things out that don't exist perhaps yet. Or perhaps those things are in a remote cluster or running somewhere else. You can't access those dependencies, so you mock and you stub. Now, when you're happy with this inner dev loop, when you've completed some bit of functionality, you then want to push it into a bigger code base or a bigger system. If you're using microservices, you may do a pull request into one service, see how that then operates in the bigger picture. Or if you're doing monolith, you just push it into a release train, perhaps on the bigger monolithic code base. Now, with microservices, many folks are moving to Kubernetes. And the problem with Kubernetes and these things is that the inner and the outer dev loop can often be the same. Not saying that TDD is a bad thing. If you're test driving your code, that's fantastic. But often we find that when you're writing code in that's going to be deployed in a container, you have to write the code, build the container, push it to a remote registry, deploy it to the cluster, and then test. You lose that really fast feedback of spinning up something on a local machine, quickly testing it, iterating on it. When you've got that container build step, and when you've typically got a remote cluster, more things are in the mix. Bottom line, this process can be slow. And as developers, one of the key things we always optimize for is feedback. Getting that fast feedback, staying in our zone without the need to context switch. Now, automation and fantastic tools do exist in the Kubernetes world to help you speed up this local development loop. Tools like Draft, I regularly bump into Scaffold from the Google team, Garden, Tilt, fantastic tools, and GitKube do some level of automation around building containers in the background. So you're coding on or something, say, containers being built and the latest layer is being pushed up to a remote registry in the background. There is a fantastic range of tools out there, but sometimes you really want that fast inner dev loop. You don't actually want to be building a Docker container. Even if something is being built in the background and being pushed up in an automated fashion, you just want to go so fast that you don't want to have that build step every time. Some projects I've worked on, for example, the build step itself takes 30 seconds or more to actually complete, and that stops me with getting into my zone when I'm coding fast and looking for feedback. And I also want to use my own tools sometime. I'm a big fan of IntelliJ. I use the IDE quite a lot when I'm coding Java. And when I'm debugging, I'm very familiar with this environment. But I obviously can't run IntelliJ in a remote cluster if I'm working on an app in a Kubernetes cluster. The first thought I had, several years ago when I was doing this development with microservices, it was even pre-Kubernetes actually, but it's extended into Kubernetes too, is can I run everything locally? Can I bring down all my services I'm working on, spin it up fast so I can use my local tools, and tools like Minikube, Micro K8s, Docker for desktop. These are fantastic tools for getting me a Docker and Kubernetes environment locally, but the biggest challenge is I can't run all my services locally. Even though I've got a reasonably powerful Mac here, 16 gigs of RAM, as a Java developer, I love Java, but the heap size is a sort of compounding factor for you can only run a few services on your laptop. Time you got an IDE running as well, it's, once you get past 3 or so services running locally, particularly if you've got some databases in the mix or some queuing software, this isn't going to happen. Enter Telepresence. This was why Telepresence was created in the Datawire team. It was effectively scratching our own itch. We were noticing this pain, and the team spun up this as a prototype tool, and it's evolved and evolved and evolved over the several years it's been running now. Let's dive into Telepresence in a bit more detail. Now, I've heard folks say that Telepresence is really a fancy Kubernetes VPN for development. I've also heard folks say it's kubectl port forward on steroids, or kind of kubectl port forward plus plus. It's effectively a network bridge between your laptop and a Kubernetes cluster. The way I often like to explain it to my fellow developers is it's like putting your laptop into a remote cluster, your local laptop in the office you're in, and it's like putting it into a remote cluster wherever that's running. And that is fantastic for running your local tools on your laptop, but connecting it up to this bigger picture, the bigger cluster. Here's how it works in a nutshell. Behind the scenes, when you run Telepresence, you run it typically against a deployment, you swap deployment. There are other ways of running this, but you would swap a deployment, and effectively under the hood, that deployment, your current service, gets swapped out for a two-way proxy that proxies any traffic inbound to that service to your local machine now, where you can run the application, play around with the traffic, do what you will, and then you can send that traffic from your local machine back into the Kubernetes cluster. And then the traffic continues going where it's going, or maybe it returns to the user, for example. But effectively, you swap out your actual service deployment with a two-way proxy that proxies traffic to and from your local machine. Not only that, but it intercepts DNS. You can access environment variables and secrets. You can access volumes as if you're in the cluster. It's like you're practically in the pod that you're running your service in, which is super useful because once you're in that pod, you're in a same namespace as many as your other services, and you're also in the file system space as well on that pod. You can also proxy TCP traffic around, so not just HTTP traffic. I found Telepresence really useful in minimizing my developer loop, minimizing the friction, the pain in my developer loop. I'm going to run you through a quick example now. This is actually from one of my O'Reilly books you can find about containerizing continuous delivery in Java. It is a very simple e-commerce app. It's actually more of a shop front, just showing products. You can see at the top here, we have Ambassador as our API gateway, open source API gateway for Kubernetes. We have our shopfront service written in Java using the Spring Boot framework. And the shopfront calls out to the product catalog service, which is another Java service written in a framework called Drop Wizard. And the shopfront also talks to the stock manager, a Spring Boot app. We are going to simulate an external customer calling in via the ingress to Kubernetes to the shopfront. The shopfront will then call out to product catalog and stock manager and return the data to the external customer. We are going to swap out the shopfront using Telepresence, and we're going to be able to inspect the traffic that's coming into our cluster and going on to the other services. Let's go to a demo. I think a demo always makes Telepresence so much clearer. If I just drop back to my desktop now, you can see I've already got a Kubernetes cluster running. If I do kubectl get services, you can see I've deployed Ambassador into my cluster. I've deployed the product catalog, the shopfront, the stock manager. Also got a rate limiter service running, but we won't use that one today. You can see the results of the application in the left window. If you notice on the Ambassador external IP, this is our ingress IP into our cluster. This is a public-facing IP, 34.74.208.16. And then if you look in our browser, I've got that IP address /shopfront, and it's actually showing our shopfront. I've got a watch on the pods in the window down bottom right. Just to prove this is all running live, what I'll now do is I'll do a kubectl logs will follow. our shopfront pod. There we go. And if I make a few requests against the website, you can see the log getting updated with the get stock call here. So this, I'm actually making a call in my local machine, calling into the Kubernetes cluster. The shopfront service is calling out to the stock manager and product catalog, assembling the results and putting the results in my browser. If I now stop that, one interesting thing, if I try to do an NS lookup on, say, product catalog, this is not going to work. As I say, I'm running my local machine here. I'm not connected in any way into the Kubernetes cluster. So in the Kubernetes cluster, product catalog is a service that has been deployed. It has a DNS domain, it has a DNS record in there, but I can't see it at the moment because my laptop is outside of the cluster. Let's now run Telepresence. I'm going to use it in the simple swap deployment mode. I'm going to swap deployment for shopfront. So you saw my shopfront service, which is backed by a deployment. I should now run this command on Telepresence. It asks for my password because Telepresence does some cool networking stuff in the background, which does require sudo access. And you can see some details going on with the logging there. You will notice in the bottom right-hand window, my shopfront has been swapped out. The pod has changed and we've got container creating there. As I described earlier, Telepresence effectively swaps my deployment for a Telepresence container. That's the two-way proxy. You can see it's all running now. My terminal's coming back to life. I should get command in just a second, but effectively we have swapped out the remote shopfront service now for a Telepresence proxy. And you can see we've got a terminal back here. This is all good stuff. So now I have swapped out the shopfront service. So if I hit refresh on my browser over on the left here, I get nothing. I've not bothered to put a fancy error page here. This is just the default Envoy Ambassador error page, give it on a 503. But because I'm not running the shopfront locally, now when I make a request into the cluster, there's nothing to serve that request. Right, with Telepresence up and running, one cool thing I can do now is an NS lookup on the product catalog. Before, when I ran NS lookup on product catalog, because my laptop wasn't part of the Kubernetes cluster, this didn't make sense. There was no product catalog DNS entry. Now, because I'm telepresenced into a remote Kubernetes cluster, when I do NS lookup name of a service, product catalog in this case, I get my domain name record back. So because I'm actually in the cluster now, Telepresence has connected me up to the remote cluster. Not only can I do things like NS look up on a product catalog service or any other service, but I can also curl directly those services which aren't exposed remotely. So there's no ingress rule set up to allow me to go to the product catalog service, but because I can curl directly into the service running in Kubernetes, if I do that, you can see I get some JSON back here. Probably more interesting, if we swap now to my IntelliJ application over here, I've got the shopfront application set up in IntelliJ. If I start it in debug mode first, just wait for this to warm up. I'll remove that breakpoint while we're warming up there. Everything looks good, should be running. So if I now swap back to my browser and do a refresh, everything works. Now you'll notice what's happening is I'm making a request to a remote Kubernetes cluster. It's going via the ingress, and that's being routed to my local machine. And you can see I've actually changed the color of the header red to indicate we're running in a local service here. But the cool thing is now is all traffic is going into the ingress but being routed to my local machine and then back up. So because I'm in debug mode, I can do some interesting things. So if I move this over to the right side and I'll put a breakpoint here. If I now refresh the page, again, it's going to the remote service, but you can see the breakpoint's been hit. If I pass it through, the web page refreshes. If I run this again, refresh, this time, if I go into my IntelliJ IDE and have a look at the data coming back, we can see before the first product name was widget here. If I have a look into my architecture here, my data structure here, I can edit widget to be kubecon China widget, set there, return that through, and voila, you can see on the right, I've now got my KubeCon China widget name for the first item in the product catalog. This is still running against the remote cluster. So I'm making the call locally to a remote cluster. There can be many things in the mix here. I've got this one shopfront service running locally where I can inspect the traffic, I can manipulate the data. Imagine the debugging possibilities. If I'm not sure what's coming from my upstream services, I can do exactly what I've done here with the shopfront, put a breakpoint in, inspect it, change the values. I can iterate very fast on my shopfront app here. And because it's hooked up to all the remote services, I don't need to worry about mocking them out. I don't need to worry about accessing data stores in that respect. Everything is like I'm running this in the remote cluster, like I'm running my laptop and all the associated IDEs and so forth as if it was in the remote cluster. Now, if I stop my application here and move the window to the right side, I will then exit Telepresence here. Look at the pod down below. You'll notice our Telepresence pod is being terminated and a proper shopfront, a proper instance of the shopfront service is being spun up. If I actually now copy the name of that pod and do kubectl logs follow, you'll see the Spring application spinning up in the background. When this eventually starts, we can do a refresh of this page and the traffic is no longer being routed to my local machine. We've exited Telepresence and everything is back to normal. Now that the Java app has spun up and is accepting traffic, we see if I do a refresh on the side, we're back to square one, back to where we were. Now the shopfront service itself is running in the remote cluster. I've lost my connection to that remote cluster now via Telepresence. Let's pop back into the presentation and finish up there. So with the demo complete, let's dive into a few more details now. The benefits of Telepresence is that any tool that runs on your laptop can be used here. Because we're proxying from the remote cluster to our local laptop, I can run my IDE locally, my profiler locally, my debugger. Providing I set a reasonably loose timeout on my ingress gateway, I can often manipulate the traffic, experiment with things before sending the request back into the cluster and actually seeing the results like I showed you in the browser there. Very useful. You can connect to cloud-based resources as if you would in the cluster. So if you've got, say, an Amazon RDS instance or an Alibaba database running in your cloud, you can access it just as you would normally in an application running remotely locally. You saw the NS lookup, same kind of deal. As long as you can access it over the network, you can access it locally now. And you get the same network space namespace there. I find this very useful just for doing NS lookups, doing digs. If something strange is going on in my cluster, quickly fire up Telepresence, run a few basic diagnostic commands, and there's a very quick way of troubleshooting strange networking issues in clusters. And you do get this very fast in a dev loop. I only hinted at some of the power you can see there when I did the example, but you can imagine if I'm coding that shopfront service and it's got lots of other dependencies, I can very quickly iterate on the shopfront service locally, hit refresh in my browser and see what's happening. And I can change to different services if I want to, I can stop Telepresence, I can do a swap deployment on another service, iterate on that one, commit the code back in, push it down a continuous delivery pipeline, move on to the next service and so forth. Now, obviously, you do need a network connection to run Telepresence. If you are running things like Minikube and other local development environments or other local Kubernetes clusters, you can do this when you're on a plane or on a train or, with no network signal. With Telepresence, because it's a proxy, it does rely on there being a connection into the remote cluster. You also need kubectl access. Telepresence bootstraps itself into Kubernetes with kubectl. Some organizations restrict access on kubectl, and that may not work with Telepresence. At the moment, Telepresence is Mac or Linux only. Some folks have got it running with Windows, but the Windows networking stack is a bit different. You can Google around and find some more information on this. And again, Telepresence is an open source project. So if you wanted to commit some code to the Windows side of Telepresence, you are more than welcome to do that. Get involved in a discussion online, and you can iterate on that kind of code if you want to. Telepresence is a CNCF project. There is lots of users all around the world. Many of the logos of companies here have either talked about using Telepresence at KubeCon, they've written blog posts, or they've shared ideas in the Kubernetes Slack, for example. One thing I see a lot on websites like Hacker News, the classic is, well, I could build this thing in a weekend. And people say the same with telepresence. Now, surely it's not hard. It's just a remote proxy, a two-way proxy. I could build telepresence in a weekend. And yeah, in reality, you probably could. The engineering team at Datawire did the same thing when they first spun up, telepresence. But we've learned over time that getting it working on your machine is very different than getting it working on everyone's machine. Capturing DNS and routings, only part of the traffic to the cluster is really tricky. No two laptops are alike. We definitely find this even with the same OS and in theory the same kind of networking stack. Subtle configurations, if you've got VPNs installed, things change. And swapping out your real deployment for a proxy deployment is harder than you think. It's a massive hat tip to the Datawire engineering team, Abe in particular. Abe is the lead developer on Telepresence. I learned so much from Abe, and he has told me many horror stories over the years about some really tricky examples that he has seen working with open source users, working with customers of Telepresence, and he has got a lot of knowledge which is now baked into the Telepresence product. So let's spend the last sort of few minutes looking at using this in your workflow. So here's the simple workflow, or the you only live once workflow. This is what I see folks using when they're a startup company, they haven't really got any customers, say, and they've got one production cluster for a single source of truth. Developer checks out the microservice code, works on the microservice code, they do a swap deployment when they need to using telepresence, and they use the basic VPN TCP mode. Once they finished using Telepresence, much like I did in the demo, they quit Telepresence, they do a pull request for their code, may get reviewed, and then that code goes into the continuous delivery pipeline, gets pushed into production, and they iterate again. Now, this is pretty much testing in production. You're swapping out services in production using Telepresence. Not everyone is happy with this, particularly managers. Yeah, so do be careful if you go down this route. If you've got customers using your website, when you swap a service out, they will be routed, their traffic will be routed to your local machine. That is not a good thing sometimes. Typical workflow for a small medium enterprise or a small medium business is they use a remote cluster for development and a remote cluster for production. So one dev cluster for single source of truth of microservices, developers check out one of the microservices, and they may coordinate with other developers. They say, oh, hey Jane, I'm going to be working on this service. I'm going to do a telepresence swap deployment. That's cool. So then Jane knows not to go in and do a telepresence swap deployment on that deployment too. Using the default mode again, typically, and once a developer has finished working on a service, they then do a build, push it down their pipeline and continue on. This is a very viable workflow. It does require a bit of coordination because if I'm swapping out a service, my colleague can't swap out the same service. And if they route traffic into the cluster that goes to my service, their traffic will come down to my laptop before getting pushed up back to the cluster. So there is a few sort of nuances where you have to coordinate with each other. Great talk here by Cesar at Devox. I put the link there. If you want to know more about this type of workflow, he did a fantastic talk last year at Devox UK. An advanced workflow, and now I've mainly cheated here and borrowed from Engel and Volker's fantastic talk by Christiana Ruggi, which I'll reference in a moment. But this is using one cluster with multiple namespaces for a single source of truth. Developers check out the microservice. They use things like Bazel, Telepresence, and IDE. And Christian talked a lot about using Bazel and Telepresence to do remote builds of services and swapping in and out. And again, once the code is done, once you're finished swapping out your service from a namespace, you use Jenkins to push the code down into the pipeline and actually get it deployed properly. But Christian, I've got the link here. I think it was KubeCon last year, KubeCon EU last year. He did a fantastic talk about the various options, various combinations of using a build tool like Bazel, Telepresence, and IDEs and so forth. This is a more advanced workflow involving namespaces and so forth, but I learned a lot from Christian on this talk. So what's next? Let's take a little look into the potential future of telepresence. At the moment, we've got the two components of telepresence, and work is sort of going on independently in those two streams, client and proxy server. One use case we're looking at exploring is about making the remote proxy persistent. Rather than doing the swap deployment and putting in a new container each time, a new proxy container, we want to make it, or we think it's interesting to make it persistent. This is what Kubernetes is built for, right? Kubernetes is really good at making sure something is continually running in your cluster. This would speed up the startup of Telepresence and would also support reconnections too. Multi-user development is a big use case we bump into like time and time again at KubeCons when we talk to folks. If you're using Telepresence as it is now, you can very easily get sort of complications where you're swapping out a deployment that's already been swapped out. It's kind of a single user tool at the moment. So we're discussing with folks around the multi-user workflow. Datawire has actually built a tool called Service Preview on top of Telepresence. That's a commercial tool, and that one works. If you imagine our early architecture I explored on the demo, with Service Preview, you're actually putting a proxy in between services. You're not swapping out deployments. You're effectively snooping on the network. And if you imagine you can make a request into the ingress and say put a cookie on that request, some kind of identifying metadata, if you pass that cookie through, then all the traffic going through the Telepresence proxy can say, oh, if this cookie is present, swap the traffic, route the traffic to my local machine. As now it's kind of, quite a heavyweight, swap out the service, swap out the deployment, route traffic accordingly. If you're actually on the wire, you can leave the product catalog running. So normal requests to the product catalog. So without the cookie, can go ahead and talk to the product catalog, data comes back and it's all good. But if the cookie's present, we can route that traffic to our local machine, and then on my local machine, I can push that traffic back into the cluster when I've debugged it and so forth. So wrapping up, we'd love folks to contribute to Telepresence. We'd love people to say, hey, yes, I use Telepresence. We always enjoy hearing about use cases. Documentation and workflow is super useful. I've provided a few examples today, but every time I chat to someone about how they use Telepresence, I learn more and more. So if you're a user, let us know. If you'd like to contribute more, there's lots of ideas on GitHub. You can pop along to GitHub. And you can also join our Slack. We have an open source Slack available there. Telepresence channel. Abe's there. Abe's the lead developer. He'll help you, get started or deal with tricky issues. Bear in mind it is an open source channel, so no guarantees on support, for example. It's always best effort. But we love to see people there. We love to engage with the community through this channel. That's it. I'll now be taking Q&A live. You can find me at db at datawire.io. You can also find me on Twitter and GitHub and so forth at Daniel Bryant UK. And you can go to the Telepresence website there at www.telepresence.io. Thank you very much for your time.